Hello, this is Dr. Scott Denstead, founder of the EZWxBrief progressive web app. Let's take a look at some flight planning for a flight from Salisbury, Maryland down to Monroe, North Carolina. Now we're planning to make this trip tomorrow morning. Here it is, Saturday around noontime, and our goal is to try to get out by, let's say, 8 a.m. around 12Z here on tomorrow on a Sunday. And so we're going to take a look at how to go through some of the weather using the EZWxBrief progressive web app. Now, one of the things that I do usually, especially this time of year where we still have a fair amount of convective potential here in the middle of September, is to look at the dew point temperature, specifically the forecast dew point for tomorrow morning. So I have my departure advisor set here about 12Z tomorrow, that's 8 a.m. And so that will give us a pretty good understanding. If you look at the layer selector here, you'll see that I have dew point, surface dew point forecast. So we're looking at pretty juicy air overall. We're talking about dew points up in the 70s, low 70s, maybe mid 60s, upper 60s over a good portion of this route. And that means we have moisture, low level moisture, which we know is the fuel for convection. So will this be a very convective flight for tomorrow, or will we not see that kind of thing? Well, we have to look at the big picture in just a bit, but this sort of sets the stage. Is there enough fuel for any type of significant convection along this route? And certainly there is, at least looking at the surface. That doesn't mean that you'll see convection along this route. It just sort of sets the stage for what we want to look for. Now, if we look at the temperature profile for tomorrow morning, let's go back to the layer selector and we'll select the temperatures. It doesn't look like they changed a whole lot, and that's just generally because the temperature and dew point are pretty much very similar. We can look at that dew point depression, which is the temperature dew point spread. And this is essentially in degrees Fahrenheit. I have that set up in my general settings here as Fahrenheit temperatures. So it's really juicy air. Anytime you see these purple colors here, we're dealing with dew point depressions of less than 2 degrees Fahrenheit. So a lot of these places we're dealing with very near saturated conditions near the surface. So we would expect, if we look at the potential for ceilings and visibility, usually we expect something lower. So I like to look at the weather layer, and that gives us an indication. You can see pretty clearly here that lots of red, which means you have IFR conditions. It could be ceiling or visibility, or both, that block that or that bring that down to the IFR category. Marginal VFR, some VFR along the coastal region, and then sprinkled here we see some marginal VFR around this. But if we zoom in a little bit more, we can see that there definitely are pretty large areas of IFR conditions. So if we're planning to take this flight, we're certainly likely to need to be under instrument flight rules, not visual flight rules, just because of that large area of IFR conditions over a large area. Now, by the time we get to the afternoon, if you wanted to postpone this a little bit, maybe not fly as early, you can see that some of this does eventually mix out and become more marginal VFR, and even VFR by the time we get to the afternoon. So if we're not going to do this trip in the early morning hours, IFR, we may be able to look at doing maybe a later flight in the afternoon as this weather tends to mix out. But we can also notice what the wind direction is as well. I like to take a quick peek at the wind direction and kind of see what's happening from that standpoint. So I'll look at the surface wind barbs, and this again shows us wind speed and direction in the early morning hours. And you notice that most of that flow is coming here off the Atlantic Ocean. You can see the wind barbs are lined up in that way for a northeast or easterly flow, depending where you are in this particular situation. So we know we have some moisture to deal with that's coming off the Atlantic, and that tends to, that's one of the reasons why we're probably seeing a fair amount of of IFR conditions in this region. And as the heating of the day kicks in, mixes out some of those lowered ceilings and visibility. So let's just take a quick peek at the visibility and ceiling just to see how low this goes. And again, this is our route here from Salisbury to Raleigh-Durham to into Monroe. We're planning a 10,000 foot flight. We'll see if that's going to work out depending on what else is going on. But if I look at the surface ceiling height, for instance, here, again, all the ceilings are in that IFR flight category in the morning hours, and eventually as we get into the afternoon hours, they tend to mix out and become more broken or scattered, and eventually go into a more of a VFR type category in terms of ceiling height. We go back to 12Z, we're going to see this situation again become such that we are looking at, let's see, some surface visibilities here. Surface visibility is not too bad overall, so it's not going to be a visibility problem. Below the ceilings itself, looks like for the most part pretty good visibility throughout the morning and the day. So it's just really low ceilings that we have to worry about here. Now we can actually look at the route profile and see what it looks like for departure around this time. And this will give us, I think, hopefully a better idea. We're going to be dealing with a lot of low IFR conditions, or if we're going to be dealing with clouds that are going to extend up to 10,000, 12,000, 15, 20,000 feet. The profile view usually does a pretty good job capturing that element here. And so, so the cloud depiction here does show pretty clearly that we're looking at a Salisbury here, probably looking at broken 2100, scattered 1400, maybe some VFR conditions early on, but then we start to see that we have those low IFR conditions right in that center of that route, all the way through Raleigh-Durham, where we'll see some of those IFR conditions, low IFR. You can see the ceilings here, the cloud covers, all down near the surface. So we would expect the possibility of a pretty good overcast layer with all that flow coming in from the northeast, laying down that IFR, those IFR ceilings, and even some low IFR in that area. And if we run this over a little bit further in the future, you'll see eventually some of those ceilings begin to lift. You can see how the profile view clearly shows that as well. And again, eventually when you get into the afternoon hours, but we might start picking up although you can see a little bit of rain showing up here, up at the top, where we see the possibility of some rain showing up later on. Doesn't show convection, but this is probably going to be very showery in some areas. So it does lend itself from that standpoint. So this gives us a really narrow view of what's going to happen, but gives us hopefully some idea of what we're dealing with here. And you can even see that there's a possibility of some clouds in the afternoon extending up, maybe up to 10,000 feet, maybe a little bit higher. So maybe a 10,000 foot, maybe we need to be a little bit higher if we want to go over this, or we could fly VFR potentially under if we leave later. Now, let's take a look at the imagery just so we can get kind of the big picture view here. So first of all, let's take a look at those Prague charts. And what we'll notice, this time of year, we're dealing with hurricane season and such, but we see a weak, looks like to be a fairly weak cold stationary, pseudo-stationary front showing up there down south. And if we run this over, what you'll notice is that by the time we get to 12Z tomorrow, about the time we plan to try to fly, we do see there's an area of low pressure here that's starting to look a little bit interesting. And if we run that a little bit further in time, I know our planned flight is on Sunday, not on Monday, but ultimately we can see that there's something developing there and eventually moving inland here. And we can then take a peek at the National Hurricane Center. I always like to take a peek at that. And sure enough, there is a chance of a cyclone formation in 48 hours in this region. So that worries me a little bit that this has some tropical characteristics. Now, if you read the discussion here, it says a non-tropical area of low pressure is expected to form this weekend along the frontal boundary that we just saw a few hundred miles off the southeastern U.S. coastline. The system could gradually acquire subtropical or tropical characteristics thereafter over the warm waters of the Gulf Stream. And we know that the flow is coming from the northeast, but off the Atlantic. And as that system moves up, it's probably going to be bringing a lot more moisture, especially that warmer, moist air off the Gulf Stream here. And a subtropical or tropical depression could form early next week while the system moves generally northwestward toward the coastline. And we saw that in the Prague charts as well. Now let's go back to the forecast here. I want to look at, again, trying to stay with the big picture, look at the GFS model and look at the 500 millibar chart. What we generally see is a pretty significant ridge here showing up, upper level high. There is a weak trough kind of trying to do something here down in the lower Mississippi Valley. And if we run this forward in time, and again, don't worry about the time as much, but what we do see is that there is that low pressure area. Let me zoom in on this a little bit. That we saw that surface is kind of lined up really close to where that upper level low there is. You can see that upper level low forms and moves inland there, and it's an association with that tropical, subtropical low that they're thinking is going to develop. May not turn into a tropical storm or hurricane, but nevertheless, it is potentially a pretty potent system for general aviation. So that's something we need to look at there. The other one I like to look at is the 700 millibar chart. Specifically, I'm looking at this red and blue lines that you see on here. That's omega. That's basically anytime you see red, that means you've got pretty good upward motion through. Not necessarily an updraft like in a thunderstorm, but upward motion, which generally we know upward air, the air that's moving upward, likes to condense out and produce clouds and precipitation, maybe even the possibility of convection or thunderstorms there. And you can see that in the overnight hours, it's very common for these tropical systems to really get their punch, especially out over the Gulf Stream, where we'll get a lot of. You can see that concentric circle of red really means there's some good rapid development potential there. And that eventually does move inland. So by the time we get to the Monday time frame, you can see there things really start to take shape by the time we get to the afternoon on Monday. So we don't want to delay this too long. We definitely want to do this trip on Sunday if possible, not on Monday morning, because we have that area of low pressure that's developing and moving inland. So there's some risk there if we end up running late, especially if we have to push the trip into Monday. We don't want to do that if at all possible. Also want to look at and focus now more on what we're looking at from a standpoint of what's happening for tomorrow morning. So one of the things I'll look at is under the Atth model, we'll look at the southeast U.S. and specifically look at this 30,000 foot ecotops. And this just tells us what are the probability, so the colors here are probabilities, what is the probability we'll see ecotops above 30,000 feet? And certainly in those situations, we'd expect convection or deep moist convection to occur in that area. So if we run this over to the morning for Sunday morning here, we see that all our route, which is essentially down from this area down through here, this is basically telling us that most of that's going to be offshore at this point. So from an early 12Z Sunday morning, we're not really looking at any major convective development in that area. Now, again, that doesn't mean you won't have some buildups here and there, but for the most part, all this is going to stay below 30,000 feet pretty reliably in this particular case. And I'll show you when we get to the SKUTs how you can really tell and feel confident that is the case. But there may be a few cells here and there that show up here, especially latter part of the day on Sunday. So if you delay your trip a little bit, you might find a few cells that may develop in the afternoon, early evening for tomorrow that might be more problematic. But the general forecast here has all those tops well below the 30,000 foot level. And if we look at the forecast radar depiction, we'll be able to see that how this is all expected to develop here. In fact, let me go to, instead of going to this one, let me go to the Mid-Atlantic. It covers all of our route here. And we only have the forecast radar from the HREF model, the High Resolution Ensemble Forecast. And if we run this over, you can see here that for the most part here, when we get to the early morning hours, what you notice is that most of the significant weather, again, is really far south, where we see some of that. But we see that cellular pattern here, which means you've got a convective process in place. But if we look at the some of this light blue area, this is all in association with some of that low-level moisture. So anytime you see this really light blue area kind of mixed in, that's usually a sign that the model is telling you there's probably a lot of low-level moisture there. And we notice that from looking at our other products on the map itself. And that you can see by the time we get to about 1415Z, late morning, early afternoon, all that light blue area goes away. But then we start to pick up again, that cellular pattern, which gives us a really good indication that by the afternoon hours, we could see a few cells pop up here. So even though you might say, well, I'm going to avoid the IFR conditions by flying a little later, you may find yourself entwined in some of this other, this forecast that you see here, where we see some of that cellular pattern. So we're going from here down to sort of central Raleigh and our Raleigh-Durham area, and then over to Monroe. So right on the edge of essentially what that will produce for us in terms of the possibility. And so let's take a peek at the, go back to the imagery here, and we'll take a peek at the forecast for specifically for the, from the Storm Prediction Center. Storm Prediction Center has convective outlooks. You notice that most of that is to the south here. So we see that we have a situation where the southern part of this is where most of the activity, convective activity, is going to be. But that doesn't mean that we won't find ourselves in a situation where we could be bumping up against some of those more juicy cumuliform type clouds, which are not fun to fly through. And certainly we want to try our best to kind of work around that. So there is definitely some convective potential south and east of our route, but this is showing less than a 10% chance that we'll run into any thunderstorms or convection that would potentially even meet SIGMET criteria from that standpoint. If we look at, for instance, here, the other element of this would be, in fact, let's just do that now. Let's go ahead and look at the airport. Let's go to Raleigh-Durham. I'm picking kind of the middle of the road, and let me just go to the mediogram here. Kind of the middle of the road thing going on. And specifically, we can look at clouds here. Once again, morning clouds for tomorrow looks pretty significantly like we saw on the route profile here, with the skies basically being overcast, likely down to the levels of, we're talking about 600, 500, 600 feet. So we're dealing with that IFR level conditions there over that. If we look at the, specifically go in and look at the TAFs only go out to 12Z tomorrow, but again, it's showing overcast 700 there. But what I wanted to look at here is the forecast discussion. The forecast discussion really is something that I do a fair amount of reading, because it hopefully will agree with what I'm seeing and give me a little bit more background information, because these forecasters are looking at this pretty thoroughly. So it's high pressure over the northeastern United States with a pressure ridge extending south to the south into Carolina. Surface flow out of the northeast, which we saw, is beginning to erode the widespread low clouds that draped the region earlier this morning. While there are still a few isolated showers across the northern counties, these should generally come to an end by early afternoon. Okay, so this is all happening today, followed by clearing across the north. However, an area of showers associated with a weak low over southeastern coast will likely move onshore this afternoon and could bring some additional showers and isolated thunderstorms across the southeastern counties. That's really not the low that we're talking about with that potential tropical system. But later on in the short term, you see here low stratus will start the day, which we saw, and that will give way to partly sunny skies. We saw that as well. High pressure of the northeast will combine with the potential of a low pressure to develop off the southeast coast on Sunday. That's that low pressure that we were looking at here on the Prague charts. The pressure gradient is forecast to tighten, allowing for increasing northeast to east winds across the region on Sunday. So it could get kind of breezy as well. So breezy to windy conditions are expected to with northeast winds 15 to 25 miles per hour. So it could be kind of interesting, at least in the center part of that route, where we might start to see some stronger winds, and then we would have to definitely check the wind speeds at our destination to make sure they're not beyond what we would like to have in terms of a potential crosswind component there. And so low stratus will start the day and then break out to partly sunny skies. So it really doesn't get into a lot of details there, but one of the things I like to look at is the skew T diagram to kind of give us a better idea of just how much this, especially in the afternoon, how much this will build. Now, when it comes up, the skew T, it only goes out 20 hours, so I want to change this over to 36 hours here real quick. So we see a little bit longer time frame, and then we'll be able to see the morning situation come up. So if we look at, let's say, 11Z here, let me zoom in on this a little bit more. What you'll see here is that, yes, there's our low stratus deck right there showing up pretty clearly. And that's 11Z, 12Z, again, that low stratus deck. But if I march this over and forward in time, you'll notice that that stratus deck essentially starts to mix out, and we get more VFR conditions. But what I like to also look at here is what we're looking at in terms of instability. So we definitely have some low-level instability here throughout the area. This red hatched area is CAPE, or convective available potential energy. And if we look at this from a standpoint of a little bit later in the afternoon, what we notice is that that CAPE is kind of limited here. That's the equilibrium level, kind of the top of this. We have this convective inhibition above that, and that's going to limit a lot of this buildup here to about maybe 12,000 feet or so. So if we go later in the afternoon, we're going to definitely see the possibility of some cumuliform type clouds, maybe building up as high as 12 or 13,000 feet. But pretty clearly, we have this situation where we are looking at a situation where this area is pretty highly capped. So we're not going to grow these into thunderstorms that are going to be up into the the 40,000 feet. We saw that with the forecast earlier, where it was unlikely to see any of these tops being above 30,000 feet. And so this even gives us a better indication, kind of drilling down to see where those tops might be, but nevertheless we could see some building cumulus kind of clouds occurring from anywhere from maybe the bases here around 3,200 feet, maybe even up a little bit higher, up to a maximum of maybe 12 or 13,000 feet through that area. So that's what I would kind of expect if we were going to be pushing this into the afternoon hours around that center part. And it would be better if you wanted to kind of try to stay away from that, maybe go a little bit further north, maybe to Greensboro, North Carolina, rather than straight down through Raleigh, if you're planning to take this trip in the afternoon. So that gives a pretty good summary of this flight from Salisbury, Maryland, down to Monroe, North Carolina, where we'll see low IFR conditions tomorrow morning, or IFR conditions tomorrow morning of some mixture of low IFR in there, going to more VFR conditions later in the afternoon.